Okay, so 6.2 introduces us to factoring trinomials. Well, one thing we want to do before we actually get into factoring trinomials is to understand what we have to do when we actually factor the trinomials. So we have these problems here, and essentially it's like a little riddle. It's like a puzzle that you have to figure out the pieces for. So let's look at this first column here. All right, we're looking for two numbers. Okay, we're looking for two numbers. And the two numbers we're looking for have to have a product that equals 28. Product must equal 28. So product means the numbers are multiplied. So something times something must equal 28. And then their sum must produce an 11. So something plus something else must equal 11. And so what we have to do is we have to identify what numbers can make both of those things true. So what are two numbers that can multiply to give us 28 and also add or subtract to create an 11? And so what you want to do, what you should do is you should always list the factors of the product. So whatever the product is, all right, that's what you want to identify. So the product we need to get is 28. So you want to list the factors of the number 28. And so what we're looking for is we're looking for factors of 28. Factors of 28 that will add or subtract to create an 11. So when we look at these pairs, 1 times 28 equal 28. But 1 plus 28 doesn't equal 11. So when you're doing this, you need to have two checks. You need to create the product and you also need to create the sum. So because we're listing the factors, we already know that these multiply to create 28. What we don't know is whether they add or subtract to create an 11. So we know that these 1 and 28 don't give an 11. 2 and 14, they would never give me an 11. 4 and 7, because I could do 4 plus 7 and get 11, and I could do 4 times 7 and get 28. And so the numbers that we would need for this would be 4 and 7. Okay, and so that's basically what we're doing. You have to be able to identify factors of some product that can also create some sum for you. And when you do that process is going to lead us straight into our factoring. So let's do another one. We're looking at a product of 12, and their sum must give us 8. So the product has to equal 12, and the sum must equal 8. So factors of 12, so you list the factors of 12, 1 and 12, 2 and 6, 3 and 4. So once you list each pair, once you list the pair, you can ask yourself, does 1 and 12 ever add or subtract to create an 8? No. Do 2 and 6 ever add or subtract to create an 8? Yeah, they can. So 2 plus 6 can give me 8. And then 2 times 6 can give me 12. So then what are our numbers here? 2 and 6. Okay? All right, so let's look at the next one. The next one we have is the product is 20, and we need the sum to be 9. So factors of 20, 1 times 20, 2 times 10, 4 times 5. And we have to create a 9 through some sum. So 1 and 20, no. 2 and 10, no. But 4 and 5, yes. I can add 4 plus 5 and get 9. And if we multiply 4 times 5, we would get 20. So we get double checks. And so we know that this pair would be 4 and 5. All right, let's look at the next one. We have a product of 8, and their sum must be negative 9. All right, so product of 8, and their sum must be negative 9. So let's look at our list. Factors of 8, 1 and 8, 2 and 4. So in this list, 1 times 8 can give me 8, and 1 and 8 can also give me 9, but I need a negative 9. So 1 times 8 is 8. 1 plus 8 is a positive 9. We need a negative 9. So if we do negative 1 plus negative 8, we would get negative 9. And if we multiply negative 1 times negative 8, we would get a positive 8. So what are our answers? Our answers are negative 1 and negative 8. Because if we add them together, we would get a -9. If we multiply them together, we would get a +8. So you have to find numbers that multiply to create the product and add or subtract to create the sum. Okay? That's what we were doing. So pause it and you try those next three that I put arrows on. All right, so first we had product of 16, and we need the numbers to add or subtract to create -10, right? So we say sum, and then we just decide what the signs are of the numbers that we choose. So when we do the factors of 16, we have 1 and 16, 2 and 8, 4 and 4. So in those pairs, I think that 2 and 8 can give me a 10, but I need a -10. So if you do 2 plus 8, that would give you +10. So I could get a -8 if I was to add them together. I mean a -10. If I add -2 plus -8, I get a -10. And if I multiply them, -2 times -8, I would get the +16. So I get the product, and I'm able to add those numbers to create the sum -10. So the numbers would be -2 and -8. Then for -10 and 3, the product is -10, so I'm going to do factors of 10. And then in that list, I'm going to try to find and identify a pair that can create a 3. So I think 2 and 5 can create a 3 for me. But if I add them, I would get 7, so it's not two positives. If I subtract and I do 2 minus 5, that gives a -3. So that can't work because I need a +3. So then I just switch the signs, -2 plus a 5. So that would give me a +3. And if I multiplied those numbers, I would get the -10. So once you do, and you have double checks, you know those are your numbers. And then the last one was -9 is the product. We need the sum to come out as -8. So when we do it, I think 1 and 9 could give me the 8. But I need to create a -8. So that would be 1 minus a 9. That would give me -8. And then if I multiply those numbers, I also get -9. So that's how you know you did it correct. Because if the sum of the values gives you that sum that they're requesting, and they multiply to create that product, then you know you have the correct values. All right. So let's see how this relates to factoring trinomials. Okay. So here I've created a trinomial. So trinomials are 3-term polynomials, right? And so they have a form, x squared plus bx plus c. All right. So it's really ax squared. But in all the ones in 6.2, we're basically dealing with where our a is a 1. So we have these trinomials, and we're trying to factor. Remember, factoring means essentially we are creating and writing some product. So our final answer should be parentheses, essentially. It should show us the multiplication that created that trinomial, right? What did this look like before we distributed it? So what we're doing is we have x squared minus 5x minus 24. So in the form of the trinomial, the c term, so this would be a is 1, b is -5, c is -24. And so in the form of the trinomial, the c is always the product. The c is always the product, and the b represents the sum. So when you are factoring trinomials, essentially when you look at your problem, when a is 1, you look at your c term. C term is the product. So you need factors of 24, so factors of the c that can add to create the b term. So we're looking for factors of 24 that can add or subtract to create the -5. That's what we're doing. So what is the product? And we need factors of that product that can create some sum of -5. So factors of 24, this is what we already did before we had it in trinomial format, right? We list the factors. And we're looking for a pair in this list that can somehow create a -5. So when we look, 1 and 24, no. 2 and 12, no. 3 and 8, I think 3 and 8 can create a 5 for me. What do I need it to make? I needed to make a -5. and multiply to create a negative 24. All right, we want to make sure let me not forget the sign. All right, so 3 and 8. 3 minus 8 would give a negative 5. Yes. And if I multiply 3 times negative 8, I would get negative 24. Yes. All right. So when you try it, if you added them, so if you did 3 plus 8, that's 11. So no, that wouldn't work. But if you subtract 3 and 8, you can get it. So what if you use negative 3 plus 8? Well, that would have given you a positive 5. So when you have the number, but the sign is wrong, try and flip the signs. Okay. So my numbers are 3 and negative 8. So what we do is we are going to create this multiplication problem here. So remember, what is the goal? The goal is to write it in its factored form, meaning what it looked like before we distribute it. So what you do essentially is you're going to split the first term and then you split that last term, right? So, but the first term is easy because it's an x squared. So the x squares just split up to be x and x because when you multiply to distribute, x times x is x squared. Then you have to figure out what you multiply to be able to create that negative 24. And again, we use the fact that we need those factors to create a negative 5 to be able to figure out what the numbers are. And so we already found that our numbers are a positive 3 and a negative 8. And so you would just put your values into your parentheses and that would be it. So all of your factors are just going to be essentially the x is split up and then whatever your signs are and those numbers. So when we multiply it back together to check it, oh my goodness, it worked. So I know I did it correct. So x squared minus 5x minus 24 factored is x minus 3 times x minus 8. All right, let's look at number 2. X squared plus 4x plus 3. So essentially what's happening here is we're looking for factors of 3 that can add or subtract to create a 4. All right, because 3 is our constant. So factors of 3, 1 and 3. All right, so 1 and 3, I can add them and they can create 4. And if I multiply them, obviously they create the positive 3. So I'm good to go. So 2 sets of parentheses. My x squared splits up into x and x. And then the factors of 3 that can create the 4 are a plus 1 and a plus 3. And our problem is factored. And again, you can always distribute it out to see if you get back the original trinomial. Okay? All right, let's do another one. All right, so x squared minus 5x minus 36. So when we look at this problem, we're going to look at the factors of negative 36, essentially. So factors of our C that can add or subtract to create the negative 5. So 1 times 36, 2 times 18, 6 times 6, 9 times 4. So when I'm looking at this list, when I get to the 9 and the 4, I see that can give me a 5. So now I just got to figure out the signs. So if I do negative 9 minus 4, that would give me a positive 5. I need a negative 5, so I'm going to switch the signs up, and I would get negative 5. If I multiply those two numbers together, it gives me a negative 36, which is exactly what I need. So now I know what my two factors are. So when I draw my two sets of parentheses, my x squared is going to factor into x and x, and then my negative 36 factors into negative 9 plus a 4. And we're finished. And you can factor it out to distribute it, factor it, and through distributing, it's already factored. You can check it by distributing it to see if you get back the x squared minus 5x minus 36. Sorry. All right, so then number 4, x squared minus 13x plus 40. So let me think. I think you should do this one by yourself. So we're doing factors of 40 that can somehow add or subtract to create the negative 13. So pause the video and you do this by yourself. Okay, so when we look at our problem, our C is a 40, a positive 40. So we list the factors of 40. We're looking for factors of 40 that can create the negative 13. So when you look at your list, 5 and 8 can probably do it for us. 5 and 8 give us positive 13. So then we have to figure out, well, we need negative 13. So let's just make them both negative, and that'll give us the negative 13. Then we would take those numbers and multiply them to see if we can get the positive 40, which we do. So x minus 5 times x minus 8. You need to make sure you use your calculator. You should put your numbers in your calculator. Remember, you already went through listing factors and how to find factors, so you should use that to help you be able to list your factors. All right, use your calculator to divide numbers to see what goes into it evenly and all that kind of stuff. All right, don't be afraid to use your calculator. It's important. All of your work on factoring is going to be scratch work, essentially. Is you trying to figure out what are the numbers that I need to make this work. You're really just trying to fill in the pieces to the puzzle, right? Given some product, you need factors of that product that can add or subtract or create whatever that sum is in the middle. All right, and that's factoring trinomials. So let's do 2 more. All right, so here we have x squared minus 3x plus 6. So we want to do factors of 6. All right, so those are all of my factors of 6, and we're looking for the pair that would create a negative 3. So 1 times 6 cannot give us a 3. 2 and 3 would never be able to give us a 3. So essentially, looking at the pairs we have, our options, these pairs can never create a negative 3. There's no way we can do anything. 1 and 6 can give us 7 or a 5. 2 and 3 can give us a 5 or a 1. There's no way we can get negative 3 with the factors of 6. And so essentially what that means is that this trinomial doesn't factor. And so one thing that we learned that a number that only has 2 factors, the number 1 and the number itself, are called prime numbers. Well, a trinomial that doesn't factor, it means that that number has only 2 factors. 1 times the trinomial itself. So there are no 2 binomials that multiply to create this trinomial. So this trinomial is considered prime. This trinomial is considered prime because the only factors of this trinomial are the trinomial itself times 1. The only way you can create an x squared minus 3x plus 6 is to multiply 1 times that actual trinomial. So it is not factorable, which therefore means it is prime. Okay? All right, then we look at x squared minus 20x plus 100. So we're looking for factors of 100 that can give us a negative 20. So pause it and you do this problem by yourself. Okay, so I listed the factors of 100. And so just right up front, 10 and 10 will give me the 20 that I need. So we should have 2 sets of parentheses, x and x. Because we need a negative 20, we should have negative 10 and negative 10. So when they multiply, they create the plus 100, and when they add to each other, they create the negative 20. And that would be it. And another way you can write that is x minus 10 squared, right? Because x minus 10 times x minus 10 is the same as x minus 10 to the second power. And so that is factoring trinomials when the a is equal to 1, right? So all of these examples had a is equal to 1. And then 6364 is when our a is not equal to 1. But there's more practice, so let's practice more problems if you need to. I have another video for 6.2 part 2 where I'm just doing examples.